Hi there everybody. Today we're going to have a look at installing the Arduino Ide into Ubuntu Linux. Now I use about three different development environments when I'm working with a lot of embedded systems, expressive embedded systems in particular. One is the ESP-IDF, which is a command line framework that we looked at in a previous episode of this. Another one is Platform I/O, which we're going to come on to. But Arduino IDE is a great way of sort of getting going with embedded systems and IoT. It's been around for quite a while now. It was a really kind of disruptive thing when the guys came out with the Arduino board platform. And originally that was based around, I think it was an Atmel core, but they've come out with lots of boards over the years and there are different cores. And Arduino IDE is now extended to work with lots and lots of other vendors' boards as well. So it's a really nice, fully featured way to get going. So I'm going to be installing into a virtual machine. You don't need to do that. You could make changes directly on your host system. I tend to prefer to do things in virtual machines because it keeps everything nice and neat and isolated, and you're fiddling around with settings, and it's nice to be able to walk away from it and you haven't changed anything in the underlying system. You make your own decision, but if you want to use the virtual machine the way I am, then go back to a previous episode on the YouTube here, and I'll take you through how to get that set up. So here we go. I've got an Ubuntu virtual machine set up. This is a version that has the ESP-IDF installed from the previous sessions. We don't need to worry about that. That's not relevant to what we're doing today. You don't need that. Now, this is just starting up. So if we give that a few seconds, and what we'll do is we'll have a run through of how we get the Arduino IDE onto the system. We'll do very basic little build of what they call a sketch, and we'll make sure that we can get that onto a device in theory. I'm not going to go through the specifics of doing anything on any specific devices. That's the next episode of this series, but we'll get ourselves prepped up and ready to go for that. So I just had to restart that virtual machine, and now we are up and running. First thing we'll do is take a quick look at the Arduino Ide Web Page for some instructions on what we need to do. So let's grab that. Downloads. We're going to work with the latest and greatest, which is 1.8.16. If we go to the Getting Starting page, you of course can quite happily work through all of this. They talk about coding online, which some people like to do nowadays. That's quite an interesting way of doing things. I prefer to develop locally on my own system. It's my preference. And you can see that the desktop IDE here supports a range of different operating systems, the usual suspects: Windows, Mac and Linux. We're on Linux, so what we're going to do is download for that. And let's get the latest from the download page. I'm on a 64-bit Linux virtual machine here. We won't contribute today, but I'd encourage you to do so if you find their work of value. And we'll download what is a tar.exe file. That's a compressed tarball of all the files that we're going to need for the installation to run up the IDE. So let's just let that come down. While that's coming down, let's go back to the instructions. And what it's going to tell us to do is to extract the files out of the package that we're downloading, and then we're going to run an installation script in a terminal shell. So before we do that, if I run up the shell that I installed in a previous episode of this, you'll see there's a bunch of stuff it's just done here for setup which is a hangover from when we were setting up for the ESP-IDF framework. And that's actually going to cause us some problems. We don't want that set up because of something that it's doing with virtualizing a Python installation, which I won't bore you with, but for our purposes as we're getting going, we're going to edit the bash rc script in our home directory, so home AJ nano.bash rc, and down at the bottom there's a line I took you through adding, which sets up the ESP-IDF, and we're going to comment that out by putting a hash at the front of that line. Control O to save, Control X to exit. With Nano, you use your editor of choice. Exit that shell, and if I open that up again, you see that it doesn't run all that gubbins, and that's what we need, that's what we want. Of course, if you didn't go through that installation last time around, you haven't got that. You don't particularly care, so that's all fine. Now, we should have the download here of the tarball for the Arduino IDE. We do. Let's click on that to open it up. You know, there's lots of different ways of getting bunches of files off the internet nowadays, you know that, but tar and compressed tar, tar.gzip, tar.xz are really standard ways of doing things in Linux. One of the nice things about this is that the files that are archived up retain their properties. So for example, if a file is set to be runnable or executable, that executable property is saved within the tarball, so you don't have to go messing around with all kinds of file setups. So that's why that's quite useful. We're in the downloads folder here where we pulled down that file too, so we're just going to extract everything out into that downloads folder and wait for that to complete. So that's done now, and we'll close that. And we'll open up our terminal again. Now, we look at where we are with pwd, print working directory, we're in home AJ Lennon. We will cd into the downloads folder and do an ls to list files. And you can see in here, there's the file that we downloaded and a new folder, list -l gives us extra information, a new folder called Arduino 1.8.16, which we will cd into. And in here we have the new files for the development environment. Now this terminal is colorized, as a lot of them are nowadays, and it's interesting just to note that we've got folders in here which are blue, and we've got executable files which are green. And that's what I was talking about with properties of files and needing to change things around so that you can run them, and how that's made easier by using tarballs. So that's all good to go, and our instructions tell us to run install.sh. Now, it's important to note there that there's a ./ in front of install.sh. That's because Linux, by default, it doesn't look for files in the current folder, which I think is a security thing. It's been that way as long as I can remember, and that's fine. But it does mean that if you want to run a file in the current folder, which isn't in the path, then you have to put that ./ in front of it to tell Linux, yes, look in the current folder, please, if you would. So we will do that. Here we go, and we run into our first problem, which is that although these instructions are telling us to run that installation script, we know it's a script because it's a .sh file extension, we don't have the permissions to install the files on our system, on our virtual machine. So that's fine. What we do here is we need to run as the super user, or the root user, who has access to installing the files sort of globally within the system. I would be a little bit worried about that if I didn't know where the code was coming from, or if I was doing this on my host system. But I know where the Arduino code has been and what they do with these guys, so I'm happy with that. And also that's part of why I use virtual machines, so that, you know, if something goes wrong, well, I can roll back from it. It's not going to break my my working system, if you like. So that's kind of why we do this stuff. So I'm going to rerun that install.sh script with sudo for superuserdo in front of it, and I'm going to enter my password, and that then is running now and doing the setup that the install script expects to be able to do on my system. So that's the first problem overcome, hopefully. Next, carry on down, it talks about going on with board-specific instructions, which we'll have a look at shortly. But before we do that, I just want to talk about the please read here, because this is quite important. Now, nowadays, most of the embedded systems little boards that you're likely to come across, like for example this one, which is, if I can show that to you, that's a tiny Pico board. Oh, it really is quite tiny, isn't it? It's pretty cool. And that's got a little ESP chip on it, and we're going to do some interesting things with that in the next session. But I show this to you to point out that a lot of these little boards and chips nowadays have a connector on, which is a USB connector. One of the types of USB, that's USB-C. You've also got micro USB A and B and older types as well. And they're there to make it easy for you to communicate with a board and to program your firmware, your software, your code into it to make it do exciting things. The usual implementation nowadays is for that USB connection to look like a serial port connection, which is a legacy thing that I won't go into with you, but you can transfer information backwards and forth as if it's just basically a bit of wire, serial connection, and the USB just makes it easier to get going with that and to talk to it. So when you plug in the board with a USB connection, which I'm going to do here into my system, what you will see, well, let's show you. So if I plug my device in, that's plugged in now. Now that's connected to the real physical host system that we're on. And what we need to do is to sort of route that through into our virtual machine. And I talked a little bit about this when we were setting up the virtual machines. And you needed to install a VirtualBox extension pack for this USB support to work properly. So if that isn't making a lot of sense to you, go back to the previous video, which is where I take you through it. What you will see and should see is that you've got a devices menu on the VirtualBox box. So this is outside the virtual machine. This is in my host system. And the USB device is there. It pops up and it shows us what I've currently got connected to my host system. And I can see that I have a Silicon Labs CP2104 USB to UART bridge. And that is that's what popped up when we connected the physical device. So the easiest way of figuring this stuff out is take it out, go into this menu, see what's there, plug it in, and what's changed, the new thing, is the device that you want to use. So you can add that in, you can click checkbox on that, and what that does is it sort of disconnects it from the systems and the host PC, host laptop, and it routes it through to the virtual machine. And if I now run dmessage, which gives you a bunch of kernel messaging out of Linux, I can see some information that shows me that a USB serial device has been attached. Well, isn't that lovely? And it says that that USB device is called TTY USB 0. To make life easier for yourself in the future, what you can do is if you go to USB settings, you can add a filter for your device here and OK that. And what that will do is it will automatically connect the device anytime you put it in, so you don't have to go through this in future. It can be a little bit confusing that, because you kind of forget what's connected to what and whether you need to sort of change it or, you know, but if you don't have to worry, that's the way to do things. So let's OK that. Next, I wanted to talk to you about these serial USB devices. Now, if we go back to the instructions here, they're talking about something called TTY ACM. And they're talking about that being in the dev directory or folder. And in our dev folder, we got loads and loads of different Linux devices. And the device is quite an important concept within Linux, but we're not going to worry about that too much. All we need to know is that in that device folder, we've got a bunch of TTY devices, and one of them is called USB 0. Now, TTY is for terminal, and a TTY ACM is a serial device that kind of looks like a modem. Again, don't really need to go into that, except to say that the two main kinds of name for serial devices are ACM and USB. And the number at the end of it is the instance. So if you've got one device connected, it'll be TTY USB 0. If you add another one, it'll be USB 1, and so on and so forth. And depending on the hardware that you're using, you will either get one of those USBs or ACMs coming up. It could be something else, but that's unlikely. Now, because Linux likes to try to remain as secure as possible, you don't necessarily have access to these devices by default, not as a user as opposed to the super user that we talked about before. So what you need to do is to make sure that when you're trying to download code across to the device or do other things with the device, you do actually have access to it, or you're going to have some problems. And the way that these folks over at Arduino recommend to do this is to add your user to a dial-out group. So we're going to do that, and username needs to be replaced with whoever you set yourself up as. In my case, AJ Lennon. You can find that out just by typing who am I, but it's who you logged in as. It's also the name in the path for the home folder that you're sitting within at the moment, if you do things this way. So I've added that user, my user, to the dial-out group, and that should give me access to the various serial devices that I need to use. Now, the thing that you need to do with this, and there's a little bit of dispute about exactly what you need to do. These folks are saying that we need to log out and log in again, which is, I'm sure, correct. Other people, depending on the systems that you're on, argue that what you need to do is to completely power cycle the system from start. So just to avoid any potential problems and to make sure we're all on the same page, I'm going to power cycle the system and bring that up again. And with a bit of luck, we will have, we'll see later on that we'll have access to the serial device. If that's going to be any kind of a problem for us, there are other ways around this. There are other things that we can do. And I'll just show you a sort of a plan B now, just in case you do run into trouble. This is always useful to know. When you plug devices into Linux nowadays, physical devices that is, the device in the tree, in our case dev TTY USB 0, magically appears. So if I disconnect my USB device, I'll do that virtually here. If we run dmessage, you'll see that the device has now been disconnected. And if I try, if I try to take a look at the TTY USB device that was there just before, you see it's gone. It's been taken away. There's a subsystem in Linux called UDEV that manages all of this, but we don't need to worry about that. So what we're going to do is virtually reconnect our serial device again and look at dmessage to see that happened. That worked. And now we're going to see if the device is there, which it is. So that's absolutely fantastic. That's really useful. If we do an ls-l, that gives us some more information about files, and devices are kind of like files. So if we look at that, we can see on the left-hand side that we have what we call access permissions to the device. And the R and W are the ones that we particularly care about, and they tell us who can do reading and writing to the device of information, which is what we want to do. You can see that the device is owned by a root user, and it's in a group which is called the dial-out group. And you can see on the left that RW, just after that C, is the root access to the device. And the second block, the second RW, is the group access. So what this is telling us essentially is that there's a dial-out user who owns the device, or dial-out group rather, and the dial-out group has read-write access to it, and we are in that group now, hopefully, so we have access to it, which is great. If that doesn't work for you, the hack is to change the access that you have to this device by using chmod a+x dev TTY USB 0. This won't work because I'm not the super user, so we'll do a sudo to do that, type our password in, and we've now changed the permissions on that device, oops, and if we look, you can see that I've added a load of permissions to it. Actually, I did that wrong. Actually, I should have done not X, so minus X. I should have done plus RW. I'm just used to executing files all the time. So if we look at that now, we've added in an RW on the right-hand side there. We've got 3 of those. And that RW is telling us now anybody has read-write access to that device. So it's not the most secure way of doing things, but for these purposes, we don't particularly care. And if you have devices connected and you have problems accessing them, this is one of the ways that you can work around that problem. You can also run everything as root, but people generally don't think that's a good idea. I'd agree with that. So this is a better way of doing things. Okay, so next. Now that we've installed the Arduino IDE, we've got a new icon on our desktop. It looks a bit strange. If we double click on it, what happens is not what we expected. It opens up a file with a load of bump inside it. And that's actually the definition of how the desktop under Ubuntu runs things. It's not really what we wanted. You can see on line 6 with exec that that's what it's going to do. It's going to run that Arduino file. That's what it's supposed to be doing, but it's not set up to do that because, you know, hey, computers. So let's get out of that, and what we'll do is we will right-click on that shortcut and we will make it allow launching. And there we go. That kind of looks a lot better, doesn't it? That's the kind of thing we might expect to see. So now we've got a nice little icon for the Arduino IDE, and if we double-click on that, good things happen, and we run up the integrated development environment. Super. So this is what you see when you run Arduino IDE. Arduino, they took the C programming language, the C++ programming language, which a lot of people know about. It's been around a very long time. People tend to love it or hate it, a bit like Marmite. And they put a sort of a front end onto it to try to make it a little bit easier for people to get into from, you know, when they're first experiencing embedded programming or IoT programming. And so if you know your C language, you might be expecting either to see nothing or to see a void main function. Here we have 2 different functions that are standard within Arduino programming. One is setup and one is loop. And you can probably imagine what those are for. The setup function is to contain things that you need to do the first time the code runs up on the hardware, and every time it runs up from scratch, that stuff will execute. It'll execute only once. It sets things up to be the way they need to be. So it does what it says on the tin. Then there's a loop function which is called over and over and over and over again. And so your main application code that's going to sit in there doing things sits in the loop function and gets called repeatedly. And that will just carry on happening until it breaks or until you power down the system. So, as I said, the Arduino IDE has been around for quite a long time and has developed a lot over the years. It used to originally just support the Arduino range of boards, and now, rather fantastically, they have added support for lots and lots and lots of other kinds of boards. You know, if we look at the, so get into tools, look at boards, you can see quite a few boards in here. And they're not actually the boards that I want to work with. I want to work with expressive boards. So what we're going to do is add in support for the expressive range of boards, which rather wonderfully we are enabled to do within the IDE. It's kind of a good IDE. So to do that, as ever, let's go back to look at our instructions on the web. And what we can do is to go and search for the expressive Arduino IDE support, which I happen to know is called Arduino Core for the ESP32. Now, there are some instructions down here on how you get all this stuff installed and run up. So let's have a look at those. And it tells you again that we support Windows and Linux and Mac OS, and that's all absolutely fine. It tells us to install the Arduino, that's fine too. And what we're going to do is install using the boards manager, the Arduino IDE boards manager. You'll see here it says this is the preferred and easiest way of doing things. I always like preferred and easy. and you see that there's a stable link and a development link. Now, Espressif are busily beavering away, doing fantastic work, bringing out all sorts of chips, and their newer ranges, the S2, I think it's an S3 coming along, C3, it's saying are supported in the dev release. So if we were going to work with those, that's what we'd pull down. But we're not going to work with those. We're going to work with some bog standard boards with ESP32 chips. And in that situation, I generally prefer, at least in the first instance, to go for stable, because stable is a good indicator that stuff is supposed to work. Dev is a good indicator that things may well not work and may change and break, and we really don't want that hassle. So let's stick with stable. And this is a link to a file on the interwebs that defines all the things that need to happen for this set of Espressif ESP32 boards to be supported. And what we do is we grab that link and then we go back to our Arduino IDE. In here we go to File, Preferences, and in there you can see additional URLs for the boards manager. You can put this URL into that space, and that's fine. You may find that if you're going to work with other ranges of boards, I mean, we'll have the Espressif support when we've done this, but there might be other boards, an XP, who knows, that you want to have a look at. So if you click on this box, you get a bigger box where you can put in multiple lines of sources for different board definition files. And that's good to know, but for our purposes, that's all we need to do. We OK that, and we've now told the Arduino IDE that there's some extra information out there that it should go and have a look at. We'll go to Tools and Board Manager up at the top here, and in there we're going to search for ESP32, and now in here we can see information which has come down after we made that change, so that we can decide to install a version of the ESP32 system, a subsystem, to be able to support these boards with the Arduino IDE. You see there's a bunch of older ones. It just tells us about the latest and greatest by default. That's what we want. So let's click to install that. So in the background, magical things are now happening. It's downloaded the instructions on what it needs to do, and it's going off to download all the different files and packages and get them installed into the IDE so that we've got the support that we need. So while that's happening, I'm gonna sit and watch. You can go and take a break, and I'll scroll this forward. I'll fast forward it for you when we're done so that you don't have to wait too long. And there we go. So we've now got that ESP32 support installed into the Arduino IDE. You can close that window and we're good to go. What we can see in Tools is that if we go to our boards, we've now got a whole range of ESP32 Arduino boards that are supported, which is absolutely lovely. If you if you know your boards, we've got a tiny Pico there with some TTGOs, some SparkFun boards, Lowlands, WeMOS, Adafruit, Olumex, M5 stacks, you name it. A lot of good stuff there, a lot of good stuff to play with. What I'm going to have a little go with shortly is the tiny Pico. So I think what we're going to do is choose that as our board of choice. You'll have to decide what you're going to work with, of course, but let's go with this for now. And then I'm going to double check that I still have my tiny Pico, which is here, yeah. So that's attached via USB, and if we look, we can see it's in fact not attached. So let's make sure that we get that sorted out. Let's take it out, run dmessage, plug it in. Okay, so we've got a USB device there. That should pop up on our devices. And yes, we've got a Silicon Labs. And you see that's got a tick next to it. You'll remember that's because I said that we could add in these filters, and that filter's worked, so it's automatically connected it up. So now we can see that we have that port available to us, dev TTY USB 0, and that's going to talk to the hardware. So let's select that as our port of choice. See down here we've got the UM20 Pico selected, and that's going to go over dev TTY USB 0, and there's a baud rate and there's some settings there for programming the device and things like that. So this is kind of really the most basic of basic stuff that we can set up within the Arduino IDE. Let's try compiling this sketch for the target board that we've got set up for the tiny Pico, and that's doing a lot of magic in the background to sort of convert this Arduino sketch into C and to compile that C, and it's failed. Now I knew that was going to happen because I've done this before, and it's a shame, but you know, this is what happens when we're dealing with open source software. And this again is why we're doing all this stuff from scratch, so that we can work out what we have that's missing and add it and have a nice clean installation. So this is telling us that Python isn't found in the path, which is quite strange. So let's run up a new terminal and let's type Python, and it in fact is not found. So if we type Python 3, that is found. Interesting. Now that's there's a lot of history to this. There was Python 2 and then Python 3, which made a lot of changes that kind of break Python 2 code. So for a long time Python 2 hung around, and then that was deprecated, and now we all use Python 3, and you can run into some trouble because of that. So we can have a look at ways to address that problem, and there are a few different ones, but the one that I want to go with, Google is always our friend with these things. You know, this is how we develop nowadays. You see an error, you put it in Google, somebody will have had it. You figure out what they did. The main difficulty is trying to figure out which of the various options you use to fix the problem. And the option I particularly prefer for this is, somebody was talking about installing Python is Python 3, which I like the look of. So let's do that. That won't work because we don't have access as a super user to make these kinds of changes within our virtual machine. So we add sudo in front of apt install Python is Python 3 and enter my password, and that will then install that particular package. And I don't know the ins and outs of it, but I suspect all that package has done is what this person was talking about, which is to link the Python 3 that we saw worked to a sort of virtual Python 2 command. So if I now type Python, or Python command rather than Python 2 command. So if I now type Python, which didn't work before, you'll remember, now it does work, and it runs at Python 3. And that's what we want. So let's go back to Arduino IDE, and again we'll do a verify and compile, and we will see if we get any further with that. And indeed we do. So we got another error, the joys of open source. We don't have the same error, so that's good. So it's finding Python now, and what it's telling us is that in the installed ESP32 tools, it's trying to do some things. It's trying to import serial, and it's telling us that a module was not found. Now, sort of wading through all of that, basically what that's saying to us is it's trying to do serial things, and that makes sense because it's going to talk to the device over this USB serial port I was telling you about. And the serial support in Python isn't there. So, okay, we can add that. The way that we add, well, there's a number of different ways that we can add modules into Python. One of those ways is to use pip, which I don't think we have installed. No, we don't. So what we're going to do is, again, use apt, which is our package management tool for Ubuntu, for Debian-based Linux distributions. And we're going to install Python 3 pip. So that's Python 3 version of the Python installer. And it's essentially, there are other ways you can do this stuff, but essentially it's you know, it's a front end to installing extra functionalities into the Python language that we might need, like serial support. So now what we're going to do is to work out how to use pip, which is now present, to install something called py serial, which is the Python serial module. and that's worked with a couple of warnings, but it told us that it's successfully installed version 3.5 of PY Serial. Good. Back we go to our Arduino IDE, and let's try to verify and compile again and see if we can get any further now. And we have success. How fantastic is that? So that's told us that our sketch, which you remember is kind of the term we use for our Arduino program, uses about 220 kilobytes of program memory, which is about 16% of the available program memory on this board. And it's telling us the maximum is about 132K. And the variables, which are what live in the random access memory, the RAM memory, use about 3% of the memory, etc., 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 etc. That's all quite interesting, you know, as we would expect with a very, very, very basic program. We're not filling up the space, and we're not worried about that. Now we're kind of getting into the next session that I want to run with you, but what we could do here now is to, from Sketch, upload. So it's going to upload the built firmware for this do nothing sketch, if you like, and that's now running an ESP tool program which has just programmed all of that over the serial link to my super duper tiny Pico board here, which is now running that code, and as the code doesn't actually do anything, doing nothing. So that's a successful installation of the Arduino IDE toolchain for us. We'll be able to use that in future. And what I'd like to do now, just before we finish up, is to clean up the virtual machine desktop there, and I'm going to shut that down like so, because what I want to do is, if you looked at the previous episodes here, I created the virtual machine, I installed ESP-IDF, we've now installed the Arduino IDE, so I want to make a snapshot of that. Arduino IDE installed, so that we can come back to a clean installation of the Arduino IDE for any kind of work that we want to do in future, and we'll know exactly what's on there and how it's configured and what we can expect it to do. So I hope that was of interest. I hope it worked for you too. And what I'm going to do next, I think, is take what we have here and have a little bit of a foray into some flashy lights. I like flashy lights. We're going to do some flashy lights on the tiny Pico board. So please join me for that. Thank you.